You are welcome. This video is a continuation of the topic solar collectors. So previously we looked at introduction. I introduced solar energy and solar collectors. We gave the outlines, general introduction to solar energy, production of solar energy, solar collectors, and solar panels. We looked at how they operate, their modus operandi, principle of operation, and we're here. So this is the second type of solar collector. The first one is the flat plate collector. Why this one is the second one? This is the focusing collector. The focusing collector works with the concave reflector. Now the concave reflector is a curved plate that helps to redirect the rays of the sun, the rays coming from the sun, to this material looking like this looks like a pipe. Now in this pipe we have blue lines and red lines, which means the blue lines means that we have inflow of fluid, which can be liquid or gas. Now as they pass in here, they are blue, which means they have room temperature or they are cold. So going through this pipe, they absorb heat from the sun, which has been redirected using these reflector plates. So the reflector plates redirects the rays of light and makes them to focus on this, which looks like a pipe. Now as the rays of light strikes this pipe, the fluid which flows through it absorbs this heat energy, then come out as red, which means their temperature has now increased, which means they are relatively hot. Here we'll be looking at the principle of operation. We have outlined the principle of operation for the focusing collector. This is just a diagram to give us a brief pictorial view of what it looks like. Then here we're going to look at the principle of operation in details. The first bullet says the focusing collector uses a concave reflector, which can be a mirror or a lens, to concentrate the solar beam. Solar beam would mean rays coming from the sun. Remember, solar relative means sun. So solar beam, rays coming from the sun. We use the concave reflector to focus or to redirect the rays coming from the sun to one point. So this now will help to raise the intensity up to 10,000 times, because we have gathered a lot of rays to one point. So the rays at that point now will become 10,000, about 10,000 times higher. The second bullet says the high intensity radiation is focused on the absorbing surface, which is insulated to avoid heat loss. The high intensity, which is now about 10,000 times, is focused on the absorbing surface. The absorbing surface is that which looks like a pipe, which collects the rays of light as what? Heat energy. And it is made to be, it is insulated so that it will not lose heat easily. Now, due to the high concentration of the solar energy, the temperature of the absorber, which is the absorbing surface, is raised to 2000 degrees Celsius. The absorbing surface, which looks like that pipe, absorbs a lot of energy. Thus, its temperature increases to about 2000 degrees Celsius. Now, if the temperature of that pipe is increased to about 2000 degrees Celsius, it means that anything that passes through that pipe, water, air, or generally fluid that passes through that pipe, will absorb heat. If you look at this, they pass here, they enter from here, the inlet, as blue. As they come out as red, which means as they pass through this pipe, they absorb heat. Let's look at the last bullet. Liquid, we're using water here, pass through a metal pipe connected to the absorber surface, absorbs heat, and then sent to the storage or usage point. I hope you understand that. Now the last bullet says that the focusing collector is movable. It is built such that it can move, so that if we do not have the sun rays coming from a particular direction, we can move the focusing collector, the device, to the direction which will help to give us a better rays of light coming from the sun. So with this, we can understand the focusing collector, that it basically uses a concave reflector to redirect or to focus rays of light to one point, hitting that point, then fluid that is made to pass through that pipe will absorb heat, then is passed to the point of usage. Now let us look at the applications of solar panels. They are used in various ways. Look at the first bullet here. Solar panels are used in heating swimming pools during cold weather. So remember, we have the outlet. After the fluid or the liquid or air is heated, they come out through the outlet. We can now move them to our swimming pool to heat the swimming pool, or for space heating. If the room or a large hall is cold, we can pass air through these pipes, then send that air into the room. It makes the room to get hot. The second bullet says heat from the plate collector or panel is used to evaporate, for evaporation of salt water to produce salt. You know what that means? If we heat fluid, we remove if fluid is heated so well, if salt solution is heated, the liquid is made to evaporate, then we have what left? The salt. So heat from the plate collector is used to evaporate, for evaporation of salt water to produce salt, and distillation of salt water or brackish water to produce clean drinking water, which means we can collect this water that is heated as they evaporate and get them as distilled water. The third bullet we have here, in homes with large family or hospitals where hot water supply is in high demand, solar plates are cheap alternative than kerosene. Once we have plenty or so much need of hot water, large families of about 15 to 20, everybody wants to take a hot bath, it means that using kerosene or electricity will be very expensive relative to using solar plates, especially in hospitals where we have so many patients that must or really need to use hot water. So using the solar plates or the solar panels to generate or to get hot water becomes cheaper. Last, the fourth bullet here. In commercial centers like hotels, car wash, cafeterias, or eating houses, laundry facilities, etc., they need lots of hot water for washing. This is basically almost the same thing as are needed in large families or hospitals. It is better to use solar panels to get heated water for our use than to use kerosene or electricity. I'm leaving you with this assignment. What are the advantages of solar energy over energy from fossil fuels? The second one is, what are solar collectors? The third one is, what are the areas of applications of solar collectors currently? So I want you to look at the current applications of solar collectors. Okay, then if the assignment is done, you forward the assignment to ofilantnigeria@yahoo.com. I want to say a big thank you for listening to this video. I hope to give you better videos and satisfy your academic need in the areas of physics, especially in Nigeria. Remember to share our channel, our link, and subscribe to the YouTube channel. You can contact us on the number showing on your screen. Drop your comments and question on the comment section. I want to say a big thank you to energync.com and New School Physics by Ayakoha, PhD. Thank you once again.